Fiber optic cabling is 100% resistant to lightning and can work in almost any electronic communication method. It just doesn't matter. It's glass. Surges, spikes, they can't travel through it. It's as simple as that. Every time I've ever pulled out my kit, I get asked about the process, and I'm here to say that with just a little bit of practice, any technician can learn this process. It's very simple. I'm going to show you a Unicam connector, and that's this right here, this little device. Corning makes this, and it with general tools, you can pretty much put a connector on. Any tech out there can learn how to do this. It's very easy, very simple. It just takes a little bit of practice. So this right here is an SC625. That's the size of the fiber multi-mode connector. Now don't get bogged down with the actual size and specs of the cable. This process is the same for all types of connectors. It doesn't matter. So the same thing with ST, multi-mode, single mode, it doesn't matter. It's the same process with the Unicam. So I'm going to slip this in right here to this, and what I have here is a laser light pen. Now you can see the connector flashing right now. I can make it steady, and this will allow us to see it. Now this laser light pen is the key to us being able to track ourselves and make sure that the light, because ultimately our goal is the light needs to shine through the fiber connector and go to the other end. I mean, that's the goal. And so we want the cleanest possible, best connection that we can possibly have. This right here is the crimp tool. Now this is one of the most important tools. It has an arm right there, and that's for crimping, and I'll get into the details later as we go through the steps. This is a cam lock right here. This little lever, it always needs to be pointed straight up. Simple as that. And so once I have my cam lock arm set up, I go ahead and slip this through and slide it into place. Slip this little lever back and let it sit in there, and with a little bit of finesse you can just have it ready to go. And so now the next step is the actual fiber. Now the first step with the fiber, put the boot on. It's so easy to forget about the boot. It's so easy to not later on. This is the final thing that you slip on, and if you forget it now, you're going to have to cut your connector. I've done it. Everybody who I've known has done it. It's so easy to do. Just put it on. Forget about it. You know. So now we're going to measure the actual fiber. Now the measurement is an important part. You can't forget about it at all. And so it always, every pack of connectors, it says it on the package what to measure it at. It even says it on this little measurement card. So I mean, you can't forget, and this gives you visual marks of just where to strip it back to and what's going on with what you're doing. So now I'm going to strip it back, and you're going to need a little bit of practice to do this, but it's not that hard. Just take your strippers and steady hand and just expose that bare fiber and get it out from under, get that buffer tube off of there. You want we're cutting it back to 40 millimeters. That was my first measurement. And nice and easy and slow, and there we go. So we have a nice clean bare fiber. And so my next step is to take my alcohol pad. It's just a simple alcohol pad, and clean it, because dust and dirt and all that stuff is just, it's your enemy. I mean, you can't have it. Clean your tools, keep it clean, keep a clean work area. I mean, it's vital to the process. So now I got my 40 millimeter strip back, and I got a cleaving tool. Now this is the most important part of the whole process, because this tool right here allows me to actually cut the fiber clean. And we want to cut it at 8.5 millimeters, and that's the same for all connectors. Anything Unicam is 8.5. It's just what it has to be. If it's not 8.5, it's not going to work right. So make sure it is. You know, you can always re-strip it and start over. You know, it's nothing's finalized yet. So we have this here. We grasp it firmly between two fingers, and I take my other hand and I'm going to snap it. And so now I got a clean cut fiber, 8.5 millimeters, and it's ready to be put into the tool. So I'm going to slip it down in here, down into the tool, put it between the rollers, and just slide it. Let the tool do its job. Don't force anything. And just slip it right in, nice and slowly, not forcing it, even when it sticks. And we should see that light go out. When that light goes out, I know I made a good connection. So that means my cleaved fiber right here and the connector have butted up against each other, and that light can pass through. It's as simple as that, and it's very important that that light goes out. Twist my cam, just do another check, make sure that there is nothing passing through there, and then every step that we've taken can be reversed up until this point. When I take this arm and crimp it, when I crimp that connector on, just put a little bit of pressure on it, it's over. I'm done. Whether it works or not, if it doesn't work, I got to cut it off and redo it. So I'm going to pull the connector out, set it down, slide my boot on. Lucky thing that we put that on first time, because probably would have forgotten. And there we go. We have a terminated fiber connection. And give it a little light test here. And we can see the light passing through it. You know, any competent technician can be trained to be efficient with this method. Ultimately, through precise measurements, simple tools, and a correct method, electronic communication can be at the speed of light.